Good morning. My name is Trevor Ponto, and I'm here today to present findings on the economic and public health impacts of air pollution in South Carolina based on modeling conducted with the EPA's COBRA tool. This presentation will walk through pollution baselines, forecasted outcomes from both reduction and increase scenarios, and explain the financial and human consequences of each pathway. My goal is to provide you with clear, evidence-based guidance to support sound legislative decisions. This presentation is designed to give you a clear picture of how changes in air pollution directly affect both the economy and public health. Using COBRA, a tool from the EPA, I've modeled two scenarios: reducing emissions by 10% and increasing them by 10%. We'll look at how these scenarios play out economically and medically across South Carolina, neighboring states like Georgia and North Carolina, and the country as a whole. This will help you make informed, impactful decisions regarding state air quality policy. The Co-Benefits Risk Assessment, or COBRA, is a screening tool developed by the EPA. It estimates the health and monetary impacts of changes in air pollutants such as fine particulates, sulfur dioxide, nitrogen oxide, and volatile organic compounds. It does this by modeling population exposure, health outcomes, and the economic value of those impacts. It's not designed for regulatory standards, but is extremely useful for preliminary legislative analysis like what we're doing today. For this analysis, I selected South Carolina as the focus state, examining the waste disposal and recycling sectors with all subsectors included. This choice reflects a growing concern over emissions tied to landfill operations, waste combustion, and recycling processes, especially fine particulates and volatile organic compounds. These pollutants are strongly linked to respiratory illness and mortality, making this sector a relevant and high-impact target for policy modeling. These are baseline emissions from the waste disposal and recycling sector in South Carolina. As you can see, fine particulate matter and volatile organic compounds are the most significant contributors. While ammonia is measured at over 400 tons, the COBRA tool currently excludes it from modeling, even though it's a known precursor to particulate matter. This exclusion may understate actual harm, especially since ammonia plays a major role in forming secondary particles that can contribute to respiratory and cardiovascular problems. I chose mortality as the focus health endpoint for the study. This outcome is tightly linked to long-term exposure to fine particulate matter, which is prevalent in the waste disposal sector. From an economic standpoint, mortality is also assigned the highest monetary valuation in COBRA because of its direct and irreversible human cost. It gives us a sobering yet clear indicator of why air quality improvements matter, not just in theory, but in lives saved. In scenario 1, I modeled a 10% reduction in emissions for all pollutants that had a non-zero baseline in South Carolina's waste disposal and recycling sector. This application was applied to particulate matter, sulfur dioxide, nitrogen oxides, and volatile organic compounds, while ammonia was excluded, as COBRA no longer includes it in health impact calculations. After modifying the emission levels, COBRA estimated the resulting public health improvements and the monetary value of those improvements across South Carolina, our neighboring states of Georgia and North Carolina, and the entire contiguous United States. From a national perspective, reducing emissions in South Carolina's waste sector by just 10% results in public health gains valued between $190 million and $380 million across all contiguous U.S. states. Of that, nearly the entire impact comes from avoided mortality. This underscores the disproportionate economic value of saving lives when it comes to air quality. Mortality reduction alone can drive nearly all of the measured benefits in COBRA. Focusing specifically on South Carolina now, a 10% reduction in air pollution from waste processing translates into between $94 million and $200 million in public health savings. Again, the majority of this benefit comes from avoided premature deaths due to long-term exposures to pollutants like particulate matter. The takeaway is simple. Small reductions in emissions can lead to major improvements in quality of life and economic savings within our own border. Even though we only changed emissions within South Carolina, the health benefits don't stop at our borders. Georgia would save up to 26 million in avoided health costs, primarily from fewer pollution-related deaths. North Carolina sees an even greater gains, approaching 93 million. This demonstrates how air pollution is a regional issue, not just a local one. Reducing emissions here has direct spillover benefits to our neighbors, which strengthens the case for cooperative environmental planning. In scenario 2, I modeled the opposite case. What happens if emissions increase by 10%, whether due to policy inaction, deregulation, or sector growth without controls? The same pollutants, particulate matter, sulfur dioxide, nitrogen oxides, and volatile organic compounds, were used. Ammonia was again excluded by Cobra even though it's chemically active in forming secondary particles. The resulting data shows the cost of such a decision, both in dollars and in lives. This table shows what happens when emissions rise instead of fall. The nation as a whole would bear between 45 million and 93 million in extra health care and mortality related cost. These numbers are negative because they represent damages, real economic losses tied directly to increased air pollution. And as with this reduction scenario, most of the losses are driven by mortality. This illustrates how inaction isn't neutral, it's actively harmful to the nation. Increasing emissions by just 10% in the waste sector would cost South Carolina up to 200 million in public health damages. Once again, most of this impact is tied to premature deaths. The cost represents increased hospitalizations, lost productivity, and preventable fatalities. The losses are not abstract, they're direct hits to the state finances, health systems, and families. Just like in a reduction scenario, the cost of increased pollution doesn't stop at our state line. Georgia stands to lose around 24 million, and North Carolina could see nearly 93 million in damages. These numbers mirror the benefits we observed earlier, but in reverse, demonstrating how South Carolina's environmental policy choices directly affect public health across the state borders. This comparison captures the full scope of what's at stake. For South Carolina alone, the difference between reducing or increasing emissions is a swing of over $400 million. The pattern is consistent across Georgia, North Carolina, and the entire U.S. Every location benefits from action and suffers from inaction. The data is conclusive. Emissions reductions don't just clean the air, they save lives and money. Pollution increases do the opposite, compounding public health and economic burdens. The implications for policy are clear. Reducing emissions by even a modest 10% yields large returns in health and cost savings. The inverse, doing nothing or rolling back protections, leads to a direct financial and human cost. Mortality alone explains the majority of economic impact, making it one of the strongest justifications for emission control. And because the benefits extend into Georgia and North Carolina, this is not only a South Carolina issue, it's a regional one. Legislative support for emissions reductions is not just good science, it's smart economics. This project highlights core economic principles in action. First, pollution is a classic externality. It imposes massive costs on society that aren't paid by polluters unless regulated. Through cost-benefit analysis, we see that even minor reductions yield outsized benefits. Meanwhile, doing nothing carries an opportunity cost. Every day we delay action, we're forfeiting lives and financial savings. Clean air is more than an environmental goal, it is a public asset with long-term economic returns. In conclusion, the evidence is decisive. A 10% emissions reduction in South Carolina's waste sector offers up to $200 million in benefits to our state alone, with additional gains to our neighbors and the country as a whole. Most of these savings come from lives saved, highlighting the human cost of inaction. As policymakers, you have a choice. protect public health and reduce long-term cost, or allow harmful emissions to continue draining our economy and endangering lives. The right decision is clear. These references include the COBRA tool itself, EPA research on particulate matter's health impacts, and supporting methodology from the national academies. All data and conclusions in this presentation are rooted in these scientifically validated and policy relevant sources.